So let's review uh, the combination and permutation. NCR NPR. And in some books or references, you may find it written like this: NPR. So instead of subscript, N is regarded as superscript. But doesn't matter how to express that. So first, let's think about. So the easiest way to understand this is to think about a situation. So when you stuck when in somewhere in the middle, uh, reconsider back the situation, and then it will guide you to the correct solution. Now, example uh, that I want to use here is, let's say you have a three person A, person B, and person C, and there are three chairs. So you want to pick them and arrange them in a row of chairs. So the how many arrangement can you make? How many different uh, arrangement can you make? Okay, so that's the question. So it could be A B C or A C B, and then you can start with B, and then A C or B C A. After that, you can start with C, A B C B A. Right. So there are 1, 2, 3, 4, 5, 6. So six six arrangement. Okay, six arrangement. Arrange six arrangements. Or simply, okay, simply you have for the first chair you have three choices: A, B, C. So altogether three choices. But if you so you have three choices, and for the second chair, because one choice has been uh, allocated for A for the first chair, then the remaining persons that you can put in B in the second chair is two, and the last chair is just one. So altogether there are six arrangement. Okay. Okay, so if there are A B C D E and F 1 2 3 4 5. So if there are six person, then how many? And you have six person, six chairs. Oh, sorry, six chairs. So that is 6 times 5 times 4 times 3 times 2 times 1. Okay. Or in the mathematics, we call it factorial. So 6 factorial. So you can do for 7 person 8 9 10 9 10 so on and so on. So the rule still the same. Okay. What if what if let's go to the second page. So what if you have let's say so it's still 3%, but now only 2 chairs. Okay, only 2 chairs. So first chair possibilities for the possibility for the first chair, there is 3. Okay. And then after one person fill up the first chair, then there is remaining 2% for the second chair. Okay, so in total there are 6. Okay, 3 times 2, there are 6 arrangement. So this is not a good example. I think better if I increase the number of person. Let's say we have we have 4 person and 2 chairs. So 4 person for the first chair, and then 3 person for the second chair. So that makes 12 arrangement. Okay. But if if it if there were a 4 chair, then the arrangement are 4 factorial times 3 times 2 times 1 24 arrangement, right? So so this is the arrangement here is much bigger than the arrangement here. Okay, I think that will make sense to you. So the generality, let's generalize this. Okay. So this is, so 12 is equal to, okay, 12 is equal to 4 times 3 2 times 1 over 2 times 1, okay, which is which is the in general they put it this way, n p r. So n here is 4, r here is 2, and that is n factorial over n minus r factorial. Okay, in the case of 3 person with 2 chair, okay, so that is let's do it over here. 3 person, 2 chairs. So 3 factorial over 3 minus 1. 3 minus 2 factorial. So that is 3 times 2 times 1 over 1, which is 6. If 3%, if 4 person, 4 chair, then 4 factorial over 4 person, 2 chairs. 4 minus 2, so that is 4 times 3 times 2 times 1 over 2 times 1, so that is 12. So that is verify our answer here. That is permutation. And then combination. So let's say there are 4 person. There are 4 person and then 2 chairs. Okay, let's start with 4 chair first. 2 person, 4 chairs. 4 person, 4 chairs. And so how you can arrange them. You can arrange them okay, this is not good. This is not good. This is not good example. Let's say 4 person, 2 chairs. Sorry, 4 person, 2 chairs. 4 person, 2 chairs. So the first chair has 4 choices, and the second chair has 3 choices. Okay, but if we disregard the position, okay, so it doesn't matter if okay, let's make some illustration. So the first chair is A. So the second chair could be B, C, or D, right? And then it could be B, first chair, and then second chair is C, A, C, D. And then first chair is C. The second chair you can have A, B, D, and then last one D. You can get E, B, and C. So the arrangement for the first chair and second chair is A, B, A, C, A, D, and then B, A, B, C, and B, D, C, A, C, B, C, D, D, A, D, B, D, C. So if we don't care about the arrangement, if you don't care, if we care about the arrangement, in total there will be 12. It's supposed to be 12. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is 12 arrangement. But if we don't care about the position, okay, so means that we can say, if we don't care about the position, so A and B is just same as B and A. Okay, so this one considered one. This one is considered one position, right? And then AC and CA also one position. So one position, one arrangement. To arrangement AD is considered same as DA. And then BA, BC is same as CB. This one. BD, DB. BD is DB. And then CD same as DC. So that's the, oh no, this is D. I shouldn't write this. Okay, so CD, the sixth arrangement that we don't care about its position. So C, D, D, C. Okay, so 1, 2, 3, 4, 5. So 6. Okay, instead of if we care about the sequence in the arrangement, then the arrangement will be there will be 12. But if we don't care about the arrangement, then the sequence, then the arrangement is become 6. Okay. So the NPR. Okay. So when we care about the sequence, just now we had the N PR, which is 4 over n, not n is 4 over 4. We have 4, and we have 4 person. We have 2 chairs. This was 12, right? Now now we don't care about the arrangement, about the sequence. So from 12 now it becomes 6. So what actually happening here is that there are your in your in your arrangement, there are two. In your arrangement, the sequence involve 2 position, okay? And those 2 position, since we neglect the sequence, okay, we can consider for example, AB equal to BA. So we can consider these 2 is the same, okay? So instead of 2, they now become only 1 arrangement, okay? So we divide by 2, okay? Similar to AC and CA. So because of there are 2 chairs, there are 2 position, and regardless the sequence, we disregard the sequence. So instead of 2, they are just they are considered the same thing, okay? Because we disregard the sequence. So further, in this example, okay, because of 2 chairs, then we divide it by 2, okay? So this is NPR over R factorial of R, and is written as NCR. Okay. So NCR is NPR over factorial of R. Okay. I'm not sure if this is the best explanation, but for the time being, let's keep this in mind. So from this relationship, we can have NCR times R equal to NPR. Now, instead of let's think about 3 person, 2 chairs. Three person, 2 chairs. So if the sequence in the arrangement does matter, then it is n PR, which is 3%, okay, and 2 chairs, okay, 3 minus 2, so that is 6 arrangements. Doesn't see if the sequence in the arrangement does not matter, it is n CR, which is n PR over R. So n over n minus R. Okay, so in the if the sequence in the arrangement does matter, you have A, B, and then A, C, B, A, B, C, C, A, C, B. So 1, 2, 3, 4, 5, 6, right? But when the sequence does matter, does not matter, so you have A, B, C equal to B, A, you have A, C equal to C, A, A, B, you have B, C equal to C, B. So only 3 arrangement. So will this prove in if we put it in the formula? So it will be proven. So n is 3, so 3%, 2 chairs, and then 2 chairs. So 3 times 2 times 1 over 1 factorial times 2 factorial. So it is 3. Okay, so the example, n is small number and r also small number, but if you are dealing with a bigger number, the rule still applied.